Hey! Hi, students. It's Mrs. E and Mrs. T. And we're here for the STEM COVID-19 blog #1, balloon rockets.
Yes, so today we're going to do a science experiment that integrates math activities as well.
Absolutely.
And we're going to work on balloon rockets. And these will be things that you can easily assess at home and obtain and be able to do at home.
You're going to be able to challenge it up and make it your own and have lots of fun while learning math and science.
Absolutely. So
right.
These are some of the materials you're going to need to have in order to this experiment. Some scissors, tape, some straws. Hey, go to McDonald's and get those pre-wrapped straws and that'll be fine. Some balloons. We have different lengths and different types of balloons. You're gonna need a string. Barbie's not included. So let's get started on our activity today. I'm gonna bring this measuring tape with me. You're gonna notice that we've cut a straw in half and we've placed it on a string and then measured the string in the backyard. Okay, so this is what our setup looks like. It's a long string attached to our play set and the chairs over there, and I have half a straw so that we can attach our balloon rocket. My daughter Madeline is out here, and we have a balloon, and we need to measure the balloon. Okay, I need a couple more puffs of, we're going to 70.
You want 70?
Yeah, can you give me couple of more puffs of air? Okay, we're measuring the circumference of the balloon. That's good. And the circumference of a balloon is the amount around the balloon. And we're going to go ahead and tape it.
The more air, the bigger the circumference. The less air, the smaller the circumference of the balloon.
I'm going to bring it out just a minute. Okay, so what we want to know is, will the amount of air in a balloon affect the distance traveled on the string? The amount of air on the balloon affect the distance traveled on the string. Are you ready? 3, 2, 1, go!
Ha ha!
That was amazing.
Nice!
Okay, so
It went the whole string
it went the
distance.
whole distance except for I would say
Measuring it in centimeters.
Yeah,
31 centimeters.
except for 31 centimeters. Okay, so we're measuring from this spot right here. So about 31 in.
Yep.
We're gonna estimate.
We're going to
that.
estimate.
All right, so we're gonna do it again. We blew the balloon up to 70 centimeters in circumference. So let's take off, let's say 10 centimeters.
Now, you should be recording your data in a frequency table that has your circumference of your balloon and the distance that it traveled in centimeters. Okay? We're going to change the circumference now. So what can you extrapolate? You can extrapolate that the distance it travels will also change. Now we're going to run the experiment again with the reduced circumference and record our data on the distance that it traveled. Here we go.
Okay, so this is 60 centimeters. And 3, 2, 1, go. Oh, looks like there's a significant difference from 70 centimeters to 60 centimeters of air. Okay, so here is my tape measure. And where are we at?
153.
Awesome. So what do you think will happen if we take a balloon and fill it up to just 50 centimeters of air? There should probably be even less distance, right?
That's right.
So let's give that a try. So when you're doing this at home, you want to make sure that you write down all the data that you're collecting. We wrote down the data for 70 centimeters circumference and 60. If you notice, we even marked on these strings. That's pretty impressive.
It is pretty impressive.
All right.
All right, so make sure you're recording your data in a frequency table so that you can plot your data when you're all through, okay? Also, be thinking about what kind of graph is going to be best to use to graph your data. Is it going to be a bar graph? Is it going to be a dot plot, a scatter plot, a stem and leaf plot? Can you use more than one? Challenge yourself. Give it a try. All right, we've gone down to what circumference?
We're at 50 centimeters.
50 centimeters now. Well, let's see.
3, 2, 1, go. Oh.
Oh, well, that's interesting.
When we have an anomaly like
We
this,
could.
we have to do it more than once sometimes.
Absolutely.
Okay, here we go.
Well, it did. It went less.
153, and you hold it at your fingers.
So that's at 153
Uh-huh.
plus 53, 63,
24.
Plus 24.
73,
Plus 20.
77.
Yeah,
77.
77.
Excellent.
All right, let's go ahead and try it again.
One more time. You can run these
40.
tests as many times as you like and gather as much data as you'd like for your graphing later.
I suggest you keep on going until your balloon just, wears out.
Absolutely.
Oops, I gotta get on this side of the. Okay, we're gonna go for 40 centimeters.
40 centimeters.
Oh, we got blown up a little bit more. That's actually perfect right there.
All right.
40 centimeters. That's a little balloon. All right. Is that our starting point?
This is fun.
Okay. 3, 2, 1, go. Okay. Well, here's a 100 centimeter mark. Right here.
There you go.
All right. So here we go. We're gonna give it a try here.
So, well, yeah. You want to go grab it, Maddie?
Okay, that's 153.
153. All right. I'm gonna hit
This is a good opportunity for you to enlist the help of your siblings or your
153.
cousins or your family members of any kind.
153 plus 153.
Make it a family activity.
306.
Okay. Got it.
Okay, and all the way to the end.
Plus 95. 306 plus 95.
401.
Oh, there we go. Sorry. Okay, that's how we measure, right to the end of the rocket. All righty.
All right.
Collecting your data.
So we've done 70 centimeters in circumference.
Yep.
60, 50, and that was 40. Let's
Yep.
do one more. Let's do a
Sure.
30.
All right, this is going to be a little baby balloon.
Oh, no.
Will
I think that's too much.
it? I think so too.
Yeah.
Oh, that's too
Hold on.
little.
Okay, keep going.
Right there, below
Yeah. Up. Hold on a minute.
You got to make sure you measure the same place every
Go
time.
Down a little bit more. That's it, right there.
All
That is
right.
a baby.
And we start at the same place every time.
Yes.
Same procedure.
Got to have your controls in place when doing a scientific experiment.
All right. 3, 2, 1, go.
I think I left
Maybe we should try that one more
I think I
time.
left the air out.
Okay.
Okay, that's
When in doubt, redo the experiment
okay. That's it.
and have a little fun. Because math and science is fun. All right. Try this again.
You'll want to make sure that you cut your straw down a size. I recommend doing a half a straw.
Yeah.
All right, 3, 2, 1, go.
Nope.
Okay, so there's a
doesn't.
no.
Not enough.
There's not enough air
To propel
to
the
move
rocket.
the rocket.
Yep.
There you go.
Awesome.
So we have collected enough data now, so that we can don't
It's okay. I'm just going under the wire. There we go.
Don't close on yourself. Now we can make a graph, a bar graph. We can organize our data. And how do you
Absolutely.
suggest we do that?
First, you got to make the frequency table.
There you
Then
go.
decide which kind of graph is best. Bar, dot plot, scatter plot, stem and leaf. You choose. And then plot your data. And then, do you see a trend? Can you estimate where a different circumference diameter balloon will land on your graph, and then test it and see if your results prove true?
Now, if you are unable to do this at home because you don't have the materials, go ahead and use the data that we've already collected for you so you can use that information.
Absolutely.
If you are able to do this at home, go ahead and video yourself doing it and make sure you send it back to us so that we can see your activity.
There you go.
And you'll want to make sure to check back on our Google Classroom for follow-up assignments. Make sure you check my Google Classroom along with Mrs. Erdberg's.
Absolutely.
All right. Thanks for joining us today, and we'll see you again tomorrow.
Bye, guys.
Bye-bye.